Good morning all. Myself Mrs. M. Vijay Sabarishwari, working as an assistant professor in a PCE department in Sri Shanmuga College of Engineering and Technology. Today I am going to share the details of source transformation. So source transformation is a very useful technique when you are doing the network reduction. Source transformation. So in source transformation, we have two types of sources in general, so that are current source and voltage source. So source transformation means we are converting one kind of source into another kind. Here we are converting voltage source into current source, in the same way current source into voltage source. So this is most applicable in network reduction theorems. So when circuits are complicated, by using the source transformation, we can simplify the network for analytical purpose. So that is why we are going to source transformations. So in this series parallel combination and even a star delta transformations also can be applied. So in generally, a voltage source is always connected, not always, if it is connected in series with a resistor and the current source is connected in parallel with a resistor. So source transformation is only applicable when the voltage source is series with a resistor and the current source is in parallel with the resistor and vice versa. Then only we can do the source transformations. For example, here look at this diagram. In this, voltage source is connected in series with the resistor R. So the voltage source is Vs, supplied voltage Vs, R means resistors. So the terminal is open here. The voltage across A and B. So when we are converting this voltage source into current source, so the voltage is converted here as a current source. So the polarity -2 plus, it is mentioned here as a upward arrow diagram. So the same resistor which is connected is in series with the voltage is replaced here as a parallel connection. So the series connection is converted here as a parallel connection. The value of I, that is current, is calculated by using the Ohm's law. So in here we know the voltage value and resistance value. So by knowing the voltage and resistance, we can easily calculate the current value by using the Ohm's law. So I equal to V by R. In the same way, the current source can also be converted into voltage source. So this is the source transformation. Voltage source connected in series with a resistor. Here one of the resistor is load resistor. So we are not going to disturb this resistor. So we are just replacing the voltage into current source. The RS is same is replaced with a parallel connection. So the RS value is equal to the RP value. Here RP equal to RS. Whatever the resistor connected is series, that same resistor is connected in parallel with the current source. So the I value is calculated by V by S, voltage by divided by resistance. So here the voltage source is converted into current source. The same way, current source can also be converted into voltage. So the same resistance which is connected in parallel is replaced here as a series resistor. The voltage value is calculated by V equal to I into R. So by using the Ohm's law, we can simply convert any kind of source into another kind. Let's see the source transformation application in example problems. So look at this problem. So in this problem, here we are having a current source parallel with a resistance. So we can easily convert this into voltage source. So the resistance 10 ohm is same resistance is used in series with the voltage. The voltage value is calculated as, here the current value is 1 and the voltage resistance value is 10. So I into R, 1 into 10 is equal to 10. So the voltage value here, it is 10 voltage. The polarity is the current in current source, the polarity is given as the head of the arrow is taken as positive, tail of the arrow is taken as negative. So the polarity is also easily identified by the using of this symbol. So this is the current source symbol. So in this symbol, the head denotes the positive and tail denotes the negative for the voltage source transformation. Then we can easily add these two resistors because these two resistors are connected in series. So 10 plus 5, it is converted into 15. Then the next step, we are converting this 5 ohm is taken here as a series. The same way 10 voltage source is connected in the same branch. So look at this. Voltage source is connected in series with a resistor. Voltage source is connected in series with a resistor. What we can do means we can do the current source transformation here. So the current value is calculated by V by R. So the V by R means here the 10 by 5 is equal to 2. So the 2 ampere current source is calculated here. In the same way 2 by 3 ampere current is calculated here. So after that we can add these two current values. So because the current flowing through the circuit is same, so we are not disturbing this 5 ohm. So the 5 and 15 are parallel resistance. So parallel resistance is converted into single resistance by means of 5 into 15 divided by 5 plus 15. So the equivalent resistance value is 15 by 4. This 15 by 4 is replaced here. So 2 plus 2 by 3. So the value is 8 by 3. The sum of both the direction of the current sources are same. So we can add at this nodal point, both the currents are summing together. So we are adding the current source 2 ampere and 2 by 3 ampere. So the resultant is 8 by 3 ampere. And the resultant equivalent resistance is 15 by 4 ohm. The remaining 5 ohm resistor, which we have to do the analysis part, so that is why this resistor is taken as a load resistor. So what amount of the current is passing through this resistor, that is what we are going to find out. So that value is calculated by using these source transformation techniques. So the final step, we are converting again the current source into voltage source, because in this diagram we are having a two loops or single node. So make them network much more easier. We are doing the one more transformation, current source into voltage source. Here 10 voltage is converted into 8 by 3 ampere is converted into a voltage source. That means we have to multiply the current value and resistance value. So finally we are getting the voltage value 10 volt. The same resistance which is connected in parallel here is replaced in series connection. So the 10 voltage source, 15 by 4 resistance, 5 ohm resistance. So the current passing through the 5 ohm is same as the current passing through the 15 by 4 ohm resistance also. So the current passing through the entire loop is same. So by using the KVL law, Kirchhoff voltage law, we can calculate the I value. So another example. So in this example, we are having a current source parallel resistance. We are having a voltage source with a series resistance. So that is converted here as a current source. It is converted here as a voltage source. Again, after that, both are converted into current source. So the current sources are passing through in opposite directions. Then we are doing the subtraction. So by using that source transformation techniques, we can easily analyze the complex electrical circuits. Thank you.